Today we're going to talk about how to balance a chemical equation. The law of conservation of mass says that mass cannot be created or destroyed. The mass of all the reactants must equal the mass of all the products. So for example, if you have H2 and you have two H's, two of them, and you react it with an O2 molecule, they will rearrange themselves to make two water molecules. Notice that you have Notice that you have 1, 2, 3, 4 hydrogens here, and on the product side, you also have 4 hydrogens. You have 2 oxygens here, you have 2 oxygens here. So the atoms rearrange themselves and stay balanced. So you have a certain ratio of hydrogen molecules to oxygen molecules that will go into making your new products. A chemical equation has to be true to this law and must always represent that law. The mass of the reactants has to equal the mass of the products. The number of atoms of the reactants has to equal the number of atoms of the products. So we're going to go back to counting atoms like we saw in the last notes. What you have to do in this section is provide the coefficients that allow the atoms to be balanced by knowing how to count atoms and how to use coefficients to count atoms. In the previous problems, the coefficients were provided for you. Now you have to figure out how to do them, how to put the coefficients in yourself. And you have to remember the atoms of the reactants has to equal the atoms of the products. So here we have HGO yields Hg plus O2. So what I like to do is I like to write out my elements that I have, Hg and O. And then I like to put them in the center and then draw lines there. What I like to do is I like to count the atoms before I put my coefficients in so I know where I need to put coefficients. So I have 1 mercury and I have 1 oxygen on my reactant side. On my product side, I have 1 mercury and I have 2 oxygen atoms. So you look and compare. The mercuries are balanced, the oxygens are not. Remember, the only thing that you can add is a coefficient. You can't just put a subscript of 2 next to the oxygen. That's like not possible. So what you need to do is you need to put a coefficient of 2 here so that it distributes to the oxygen and turns that into a 2. So now the oxygens are balanced, but oftentimes when you put a coefficient in, it will mess up another atom. So because the Hg is also attached to HGO, it also changes the Hg to 2 as well. So then you got to go back to the product side, and by putting a 2 right here, that changes those mercuries to 2. So now your mercuries are 2, your oxygens are 2, and your coefficients have balanced the equation. There is a 2 HGO ratio to 2 mercury to 1 oxygen molecule in this reaction. Let's take a look at this one. This one doesn't have a line here, but you can draw it in if that makes you feel better. We have N and we have H. Don't draw the subscripts because those are what you're going to be counting. We have 2 N's, we have 2 H's on the reactant side, and we have 1 and we have 3. So here, neither the N's or the H's are balanced. So what you're going to have to do is play around with it. So there's no way I want to turn a 2 into a 3 or a 3 into 2. It's impossible. So what you have to do is, in this case, you're going to have a common multiple of 2 and 3, which is 6. So if I don't want to put a 6 here, I want to put a 2 here. Because remember, the 2 times the 3 will give me the 6 that I want. In doing that, though, it changes the N's to 2. So then actually that solves my nitrogen problem. I now have 2 nitrogens. But then my hydrogens, I need to come over here and add a 3. If I add a 3, my hydrogens are now balanced. So the correct ratio in this equation is 1, 3, and 2. You don't have to put a 1 here. If you want to, you can, but it's really unnecessary, and you'll never see a 1 as a coefficient. It's understood to be 1 if nothing is written. All right, here we have K, that's chlorine, that's not I, that's Cl, and we have O. So we have 1 K, 1 Cl, 3 O's, one K, one Cl, and two O's. The thing that is unbalanced are the O's, so I need to make those a multiple of 6. So if I put a 2 here, I change that to 6. It messes up my K's, so that changes to 2, and it changes my chlorines to 2 as well. So then I come over to my product side, and I have to put a 2 here to balance the K's and to balance the Cl's, and then I need to put a 3 here to balance and fix the O's. Take a look at this one. We have Mg and we have O. We have 1 and 2. We have 1 and 1. So I can only put coefficients in front of my reactants and products. So if I put a 2 here, changes that to 2, changes that to 2. The oxygens are good, the magnesiums are not. So I'm going to come over here and put a 2 there, and now I've balanced my magnesiums. BaSO4 plus C. So I have Ba, I have S, and I have O, and I have carbon. I have 1 barium, 1 sulfur, 4 oxygens, and 1 chlorine, no, 1 carbon. 1 barium, 1 sulfur, 1 oxygen, 1 carbon. Let's do the oxygens first. I have 4 and 1. So let me put a 4 here. Gives me 4 oxygens, 4 carbons. And then I come back to my reactant side to put a 4 there. Now, if you notice, you do have a polyatomic. You have SO4. If SO4 appeared on this side as SO4, something SO4, what I would do is I would treat SO4 as if it was an actual element. So I would balance my SO4s. But you can't do that for this example because SO4 does not appear as SO4 here. It is broken into S's and O's. So when we get to a polyatomic example, I will show you that, but I just wanted to mention that here. All right, here we have Li, H, and O. We have 1, 2, and 1. We have 1, 3, and 1. So here you may think to yourself, well, the hydrogens are 2 and 3, so maybe I should do that multiple of 6 rule. But I will tell you it's not going to work in this case. The reason it's not going to work in this case is that because hydrogen on the product side is located in 2 spots. So you really can't make it a multiple of 6 because you'll go around and around forever and it still won't balance. What I recommend you doing for this one is making hydrogen a multiple of 4. So if I put a 2 here, I have 2 hydrogens from LiOH plus my 2 hydrogens from here. That will give me a total of 4 over here. And so if I come over here and put a 2 in front of this hydrogen, I'll get a 4 there. Now, going back to the first step, I messed up my lithiums. I now have 2 here and 2 here. And so I need to put a 2 in front of this lithium. And then the 2 distributes to that oxygen to make that 2 as well. So sometimes it's sort of a trial and error. You're going to balance some of these and they may not balance at first and you may have to go back and redo them. And that's okay. And that happens until you kind of get used to balancing. All right, let's take a look at this. And once you get good at it, you don't even have to write out the elements. Like this one you can probably look at and just see that there's 2 oxygens here, so I need a 2 here. That changes my F's to 2, so I need a 2 over here. Sometimes it gets harder and it won't be that simple, but a lot of them, once you get good at it, you probably don't need to write out the atoms counting. Here we have 2 chlorines, 3 chlorines, so I'm going to put a 3 here and a 2 here to balance the chlorines. That changes my iron to 2, so I'm going to come over here and put a 2 there. Skip that, skip that, skip that one. There are a couple tricky ones. Let me see if I can find the tricky ones. All right, let me do these 2 because these are sort of tricky. So we'll kind of put a star. Oops. Kind of put a star next to these. And let me show you why these are tricky. So you have C's, H, and O. Let me go ahead and count your atoms. 2, 6, and 2. 1, 2, and 3. So this happens a lot of times when you have a combustion reaction where you have a carbon-hydrogen molecule and it's reacting with oxygen and you make CO2 and water. A lot of the times they will not balance easily. And so you have to do a little trick in order to balance them. My recommendation is if you have an equation that is set up like this, where you have a CH compound and an O2 compound making CO2 and H2O, balance the carbons first. So put a 2 in front of this to make this 2 carbons, and that gives me 4 hydrogens plus this one, that gives me, oxygens, that gives me 5 oxygens. Balance the hydrogens next. We have 6 over here, we have 2 here, so let me add a 3 here. That gives me 6, and then it changes my oxygens to 4 plus 3 gives me 7. So here is the magic step. Do not blink. This is a very, very tricky thing, and people get really confused about it. The oxygens are not balanced. We have an even number of oxygens here. We have an odd number of oxygens here. The oxygen on the reactant side appears in one spot. So you can put any number there that you want and it will not mess up the C's or H's. But there is no way to turn an even number of 2 into an odd number of 7. There's no way this 2 is going to become 7 with a whole number. So here's the trick. The only number, whole or fraction-wise, that will make those oxygens the number 7 is if you put a fraction 7 over 2. If you put a fraction over 7 over 2, remember the 7 over 2 times the 2, that gives me my 7 oxygens that I need. So by putting the fraction 7 over 2, I have balanced the equation. The problem that you know and that you're saying to yourself is that you can't have a fraction as a coefficient. The coefficients have to be whole numbers. So in order to keep the ratio of 1 to 7 over 2, 2 to 3 intact, and get rid of that denominator, you have to multiply all of the coefficients by the number 2. So what you're going to do is you'll multiply this coefficient by 2, since there's nothing there that is 2. You're going to multiply, shoot, why did it do that? Darn it. Shoot, I was like so close. That was very inconvenient. So there's a 2 there, there's a 3 there, there's a 7 over 2 here. So you're going to multiply this by 2. You're going to multiply 7 over 2 by 2, which just turns that into 7. You're going to multiply this by 2 to give you 4, and you're going to multiply this by 2 to give you 6. So now the ratio is 2 to 7 to 4 to 6. If you go and look and see if everything's balanced, you will see that the ratios have kept the balance intact. You have 4 carbons, you have 4 carbons. You have 12 hydrogens, you have 12 hydrogens. You have 14 oxygens, you have 8 plus 6, 1, 2, 3, 4, 5, 6, 14. So that is a way to get around if your equation is not balancing correctly. And let me just show you one more time what that was. You have a 2 there and you have a 3 here. If you need, you have 2 oxygens versus the 7 over here. If you have an even and odd number, you can put a fraction to balance the oxygens here. And then in order to get rid of that fraction, everything has to be multiplied by the number 2. There are a couple of examples in your homework that you will surely struggle with. So if you're struggling, go back to this part of the video and watch this part again. All right, here is where I promised you that I would have a polyatomic for you to balance. So here I have aluminum. I have OH, which is a polyatomic. I am not going to write it as OH. I'm going to separate it into O's and H's. And the reason being is that over on the product side, it has split into something else besides hydroxide. So I cannot balance it as a polyatomic. Okay. However, I have SO4 over here and I have SO4 over here. So I am going to go ahead and write SO4 as if it was an element. Okay. So for aluminum, I have 1 aluminum. For oxygen, so I have 3 oxygens from here. And I am not going to include this oxygen from SO4 because I'm going to include that oxygen when I go to balance with my SO4s. For the hydrogens, I have 3 hydrogens here plus 2 here. That gives me 5. And then my SO4s, I have 1 SO4 here, so I'm going to count that as 1. On my product side, I have 2 aluminums. I have, how many SO4s do I have? I have 3. I have 2 hydrogens and I have 1 oxygen. Okay, let's go ahead and balance the aluminums first. We'll put a 2 here, gives me 2 here. That changes my oxygens over here to, so this is 2 times 3. That gives me 6 oxygens and 6 hydrogens. Oh, but then I have these 2 hydrogens too, so I actually have 8 hydrogens. So that takes care of the aluminums. Let's balance the SO4s next. So I have 3 over here, 1 over here. Let me put a 3 here. So that'll balance that. And then it changes my hydrogens to 6 from here plus 6 from here. That changes that to 12. Okay, so then I need to go to my product side and I need to balance my H2Os. So if I put a, what do I need, a 6 here, that gives me 12 hydrogens, that gives me 6 oxygens, and I'm good to go. Okay, so that is sort of a more challenging one. Your worksheet is probably going to be a lot of this example and then another of the challenging ones, which is that fraction trick over there. Okay, please don't overpass the fraction trick because people are like, oh, it's too hard, I'm not going to learn it. And then for the rest of the year, every time we have a balancing equation that requires a fraction, they don't know how to do it. So learn it now because it's not going away. And that is where we will end for today.